Hello everybody, welcome back to the channel kaviwebdesigns. Now today we're going to continue with our fourth lesson, which is React Native hooks. So we're going to learn about useState, useEffect, useRef, useCallback and useMemo. So now we're going to implement them in React Native. Before we get into the code, I would like to give a demonstration. So now if you look over here we have our application. So our header over here, we're using Stack Navigator. Over here we have React hook examples. Then over here we have this list over here where we have some cards, and over here this is a scroll view. So over here we have our useState, which is an increment decrement counter, useEffect where we have a timer which counts. Then we have useRef where we focus on the input. Then useCallback, and this we need the console for. So like when you click this expensive operation, it will calculate that expensive operation, and over here perform expensive calculation. But this over here where we don't have useCallback, when you press it, it didn't calculate it again, as because we have useCallback. Then over here we finally have useMemo. We are using factorials. Over here we already casted 1 to 20 factorials. So if I do 20 over here, instantly in a split of a second it will calculate it for us. And if you go to your calculator, it will also calculate in a split second. But over here in some computers, it might take some 1 second or 2 seconds to calculate it. Alright, so first let's learn about useState for local state management. So what does it do? So what it does. So I'm going to tell you what it does. So useState lets you store and update data within a component. It's how your screen remembers things like user input, toggles, counters and loading states. So why does it matter? In mobile apps, we constantly need to reflect user interactions. useState helps us maintain interactions in memory so that the UI can react accordingly. So let me tell you some real-world examples of useState. Suppose in login screen when you need to track the entered email and password, or in a shopping cart where you might want to store the selected item quantity. Then you might also want to use it in a quiz app where you would track which option the user selects per question. Now let's go on to useState. So what does it do? The hook handles that anything you need to happen after your UI has rendered. The things outside React's direct control. So why does it matter? A lot of apps' behaviors depend on external events or conditions. Fetching data, setting timers, subscribing to changes, or cleaning up resources. So let me tell you some real-world examples. You can also use it when fetching product data or an API. So now let me tell you some real-world examples, such as fetching product data from an API when the app screen opens, or starting a timer for a quiz or a countdown, subscribing to devices, orientation, or offline/online status. And there's a bonus to useEffect is that you can also clean up when the screen goes away. So this cleanup over here is a cleanup function that we return as a useEffect, which you see when we use our example. So then we have useRef accessing values without re-rendering. So what does useRef do? useRef gives a way to store a value or reference that doesn't trigger a re-render when it changes. It can also be used to reference UI elements directly, like focusing a text field. So why does it matter? Sometimes you want to store values silently, like how many times a button has been clicked without affecting the screen's layout. So some real-world examples are automatically focusing on a text input when a screen loads, sorting a timer ID so that you can stop it later, or tracking whether a user has scrolled to the bottom of the list. Then we have useCallback, which prevents recreating functions. So what does this hook do? This hook remembers a function so that it's not recreated every single time when your screen re-renders. It helps optimize performance by avoiding unnecessary calculations. So why does it matter? If you are passing a function to a child component and the function keeps changing, it's causes unnecessary re-renders. useCallback stops that. So some real-world examples are keeping a consistent reference to a function that filters a list, or avoiding re-renders of child components like a custom button or a card that receives event handlers. So then we have our last hook, which is useMemo, which prevents recalculating expensive values. So what does it do? The hook caches a computed value so that it can only be recalculated when necessary. So why does it matter? If you're calculating something heavy, like filtering a large list of factorials, you don't want to redo it every time the component updates. useMemo optimizes this. So some real world examples: sorting or filtering a long product list only when the filter changes, and calculating stats like average score from a very big data set. Alright, so now let's get right into the code. Alright, so now over here I have already done npm start, but before that you should run npm install then start, so that you would have the dependencies and then you will start it. So now over here, if you see, there's a source folder. If you look over here, there's a source folder, and in there there's components and screen. So over here we are importing React and useState. So now over here we are saying const, and we are array destructuring of two things: a function and a variable, calling our useState function and passing the initial value as 0. So over here, let me explain what these two things are. So this is a variable. So this is constantly being watched by React to see if there's any changes or anything like that. So, and over here, this is a function that will set this count, so they might decrement it or increment it. So what this does is change the value of count. Alright, so now over here we have returning a view with the style of container. I'm not going to go into the detail with style, but over here I'm going to explain it a little bit briefly. So our container over here is a view. Then we have a text over here that displays the count. So to display the count, we just use a count. We just use this simple method over here where we put brackets and just say our variable, which is count. Then over here we have another view, and over here we have two buttons, an increment button and a decrement button. So here, that's why we're giving the title as increment and decrement. So for the increment button, we have on press, we're giving it an arrow function, and we're saying set count to count plus 1. So what this does is, if the count is initially 0, it will add 1 to it, and for decrement it will minus 1 for it. Alright, so now let's look at our example. So now let's go to our useState, and over here we have our decrement and increment button, and also we have our count title. If you increment, you increment. And you may ask, how is this happening? As because just as I told you, React will always observe if this variable over here has changed and re-render the entire component, so to update that change. So that's why over here this seemingly going up and down, and over here this can also go to negative values. Alright, so now let's move on to useEffect, which is a simple timer. Alright, so now over here, for useEffect to be useful in a timer, we also have to have useState. So now over here, what we're basically doing is we have the seconds over here, and we also have is running, and over here we have a useEffect. So what useEffect does is handle side effect. Alright, so now over here we have this. So useEffect accepts a function and a dependency array. So you may ask, what is a dependency array? So the dependency array is what makes this function over here run. So when this value has changed, it doesn't care what is in that value. When this value has changed, it will run this function. So in this function, we have declared a variable called interval id. Then we're checking if is running is true. So if is running is true, then we'll run this code where we set an interval, and every 1000 seconds we update the seconds variable to previous plus 1. And over here we have this cleanup function. So this cleanup function runs only when we navigate out of the screen. So when we're in the home page, this cleanup function will run, so it will clean up it will clear up interval id. So then over here we have this button over here, we have the title. So if is running is true, then we say stop, otherwise we set it to start. Then over here we have a text timer, and we are doing the same thing where we did in useState, where we say count and put the value as count. Over here we are saying timer and timer in seconds, and we also put a S for the value. Alright, and over here in this button over here, we have this on press where saying set is running to not of is running. So this means that if is running is true, then we set it to false, and if is running is false, like the initial value now, then we'll set it to false. Then over here we have this button where we reset it. So on press, we set the seconds to 0. Pretty easy, right? So now let's check it out. So now here we have the timer, and it'll count in seconds, and because over here we are passing 1000 milliseconds, So 1000 milliseconds is just 1 second. We can reset it and it will become 0 and we can stop it. So now let's go to focus input. Over here we're using a useRef. So here we have our component. Then over here in there we have declared a variable input ref, and we're saying we are giving the value of useRef and initial value of null. So now over here we also declared a function called focus input, where we said input ref, which is our useRef, dot current means the current value, whichever element has this ref, whichever element over here has our ref, we're gonna focus on it. So that's why we put current over here. And over here we have this view and we have this text input, where over here we have set ref, which is a property which allows getting a ref to the component instance, and we set that to input ref. Then over here we have this button, we have a type of focus input, and we just call focus input, not the component but the function. Alright, so now let's check it out. So now over here in the component we can type something over here. So I'm going to type gibberish. I'll go back, go on useRef, our thing is now refreshed, and I'm not doing anything. I'm just clicking this button and it's automatically focusing there. Pretty neat, right? So now let's go back to useCallback, which is a little bit complicated, but you will understand it. So the useRef is expensive button. So over here we're first importing useState and useCallback. Alright, so now over here we're first memoizing this child component over here. Then over here we're setting our states. Then over here we are also having handle expensive operation. We're using useCallback, and over here we're setting count to c plus 1. So we're passing the argument c and we're incrementing it. Then over here we're simulating an expensive operation, where we're basically just using a for loop and counting to this number, which I think is million. Yeah, which is a million. And over here we're putting an empty dependency array, since we're using function updates. We have this also handle other state update. This will cause a re-render, but it won't affect this over here because we have memoized our callback. So then over here we have our UI. Over here this component won't re-render unnecessarily, and over here we have another button over here. An on press will handle this state other state update. We will just update this variable, and over here this will also update this variable and perform an expensive operation. And over here we have the side note, so if you want to read it, just pause and read it. Alright, so now let's go to useCallback. Then over here you can click me expensive operation, and if you look at our terminal over here, it says performing expensive calculation. So I can click it again. So I click it 3 times, and over here we see performing expensive calculation 3 times. But when you say update state, this over here function doesn't run again. So useCallback, what it does is prevent unnecessary re-renders and unnecessary recalculations. So now let's move on to useMemo. So over here we have created a simple factorial function. So here we see const factorial. We're saying useMemo so that we cache in all the factorials from 1 to any number, any given number. Over here we have some if statements, a single line if statement. So if so over here we have this useState, right? Over here if you look, we are passing in a string number, and over here what we are doing, and over here we have this text input where we're getting that number. So it kind of makes sense, as because from our text input we only get a string number and technically not a real number. So here what we have to do is first we parse integer so that we can get it to a regular integer, and then what we're doing is we're checking if is NA. So if number is NA, then we return invalid input. Otherwise, if the number is negative, then we say cannot calculate factorials of negative numbers. Or if number is greater than 20, we say number too large. But if all of those checks are true, if all of those checks are false, then what we do is we move on to calculating our factorial. So we say let result equals 1, and for let, so now over here we say I equals 2. So I should be greater, so I should be lesser than equal to number. We increment I, and result is we multiply I. So here we say I equals I times itself. So here we're saying the result is equal to I times result. Then over here we return result to a string, so we convert it back into a string, and over here we run this whenever the number has changed. So this useState over here, whenever this has changed, it will be run. Then over here we have this text input where we are saying set number, so we are setting a number every time we type to number over here, and the value over here will be our number. Then over here we set maximum length to 2, as because we only need numbers to 20, so we'll just put it as 2. And over here we have our result where we just simply give factorial, which is our answer. Alright, so now let's go to useMemo. So now over here I'm going to type in 10 factorial, which is already a huge number. Let me type 15, which is also a very huge number, and then 20. So now over here we see a very big number in the split of a second. Alright, so now over here if I type in -1, cannot calculate factorial of negative numbers. If I type in A, B, C, it will say invalid input. So we have to type in things. So if I say 0, 0 times it, so over here it says 1, which is kind of an error, as because 0 itself a factorial, and it will result make. I also don't know about factorials, so my result is 0 or 1. 2 will result 2, as because 2 times 1. 3 is 3 times 2 times 1, so it will be 6. 4, 24, 5, 150, 6, 7, 20, 7, and so on. So now over here we can change this to a really huge number like 1,000 or 10,000. But I'll keep it to a small number, relatively small number like 100. I'm going to change the maximum length to 3, and let's try changing it to 100. So 100, and over here in the split of a second we get this huge number. And folks, try it out using a calculator. It will give a math error, as because 100 factorial is a really big number over here. So that's why over here we put exponential digit plus 175. Alright, so now you may ask, how do you get these beautiful cards over here? So that is simple. In screens we have a home screen, and over here we have our data that's has our title, description, color, and screen. And over here we have used a stack navigator, and basically what we have done is just mapped over it and put a hook card, and that hook card over here is this component over here. And also we have got our screen width, which is dimensions.get window.width, so that we can have some responsiveness. Then over here we have also a scroll view over here, and that is nested in a view that has hooks.map. Then over here we say hook and index. We're giving the key as index, as because whenever we use a map function we need to give the key. The title as hook.title, description as hook.description, and color as hook.color. Then on press is navigate, navigation.navigate, hook.screen, as because over here we are object destructuring out navigation, which is always here, as because in app.js we have the stack navigator, so it's available to home screen where we can use navigation.navigate, where we can navigate to any screen we want, but we just want to navigate to hook.screen. And over here we have our styling that makes all of this possible. So folks, that's it for today. Thanks for watching, and if you want any website or mobile app, be sure to contact me. Have a nice day, and this is Ishang signing off.